In this video, I'm going to take you through parallelogram law. Parallelogram law is a law used for simplifying two or more forces or vectors acting at a point. If you have forces acting at a point or on a particle, we use parallelogram law to simplify the resultant of these forces by taking two at a time. So parallelogram law basically involves two forces at a time. Now, parallelogram law states that if two forces act at a point representing the adjacent sides of the parallelogram, so let's say force 1, force 2, they are acting at a point and they represent the adjacent sides of a parallelogram at an angle alpha, then the resultant of these two forces is the diagonal of the parallelogram. So this is the resultant from parallelogram law. So whenever two forces is acting on a particle, hence they will meet at a point at any angle, and if the two forces can be represented as the adjacent sides of parallelogram, then the resultant is what is on the diagonal, that is R, the diagonal of our parallelogram. So you only complete the parallelogram, then you find the resultant. In this video, I'm going to teach you how to find the magnitude and the direction of the resultant step by step. So now let's see. If you have force 1 acting at a point to force 2, and you want to find the resultant of these two forces acting at an angle alpha, parallelogram law is saying that the resultant is a diagonal, right? So you draw your diagonal like this. The next thing to do is, one property of parallelogram is adjacent sides add up to 180. So this plus this will add up to 180. Hence this side alone is 180 minus alpha. Once we get this done, in parallelogram, parallel sides are equal. If here is F1, here is also F1. Here is F2, here is also F2. Now, we then split this into 2. But to make simplification easier, we choose this section of our parallelogram, this triangular section, where here is our resultant. So you will draw that part with your R, then with your force 2, F2, then with this side which is on F1. That is, you separate this. So what that we want is this angle. Once you get this angle, we take this triangular aspect out. Here is our R, here is our F2, here is our F1. Here is 180 minus alpha. Once you have this, we are good to go. We can now use the cosine rule to find out our R, because cosine rule requires us that you should have the opposite angle of the side you want to find and is present. Then there should be at least two known sides, and you know F1, F2, and this is just an illustration. So here, by cosine rule, R squared will be equal to F1 squared plus F2 squared minus twice their product, F1, F2, then cos 180 minus alpha. Hence, our R is simply equal to the square root of the expression F1 squared plus F2 squared minus twice their product, then cosine the angle 180 minus alpha. This gives us the magnitude of our resultant. Now let's see the direction. Now whenever two forces meet this way, you find the direction of the resultant. See, this is the resultant. So the direction will be the angle down here, and let's say it is beta. So when you are redrawing this part, this triangle will carry the what? The direction B. And whenever you have at least two angles with two known parts or one known part, you can find one unknown side of a triangle. So now let's see. Since we know here to be B, here is 180 minus alpha, our R, F1 and F2. By sine rule, you can find the value of our beta, that is the direction. So sine of this angle over the opposite, and 180 minus alpha over the opposite side R should be equal to sine of the beta over what F1. This will be known because we know the value here. We know this angle, so we can find out B by multiplying F1 by sine 180 minus alpha all over R because of sine B. Then B is simply the sine inverse of this whole expression F1 sine 180 minus B all over R. Now let's take an example so you understand what I'm saying. So using parallelogram law, let's find the resultant, that is the magnitude and the direction of the resultant of the two forces, 3 meeting, 4 meeting, and the angle between them is 60 degrees. So we have to use parallelogram law to solve the resultant, the magnitude and the direction of the resultant of these two forces. You can see that these two forces are acting as a point and they represent clearly the sides of a parallelogram. Hence, the resultant can be found using the parallelogram law by introducing the diagonal. So this is equal to, you draw your diagonal. Here is your 3 meeting force and this is the 4 meeting force. This whole part is a 60 degrees and this is our R, the resultant. When you draw this, you draw this. So once you get this, the resultant R here has a magnitude which you find, then the direction will be this side, let's say beta. So now to find the magnitude of R, I told you that you separate this part of the triangle when you find the angle here. In a parallelogram, the sum of the adjacent angle is 180, so here will be 180 minus 60, and that is what 120. So here will be 120 degrees. Then I take that part of the triangle out. So 120, I have here to be the beta, where that is the direction. Here's my R, and this is, so see these 3 meetings, so in parallelogram, parallel sides are equal, here will be 3 meetings. So I have 3 meetings here, and I have 4 meetings here. So at this point, using cosine rule, R squared will be equal to 4 squared plus 3 squared minus 2 multiplying 4 times 3. Sine of the angle between them, which is 120 degrees. So my R is simply equal to this square of this expression. 4 squared is 16, 3 squared is 9, so 25. 4 times 3 is 12, minus 24. Sorry, this is cos of that angle. So let me show you the cosine angle I take here, so cos of the angle. So cos of that angle. So 24 cos 120 degrees. And this will give us the magnitude of the resultant. The square root of 25 minus 24 cos 120. So the answer I'm getting is equal to, my resultant is 6.083 meters. So now, once I have the magnitude, I move straight to finding the angle, that is the direction of my resultant. So I'm going to redraw, and I have my R equals 6.083, my F1 to be, here is 3 meeting, so 3 meeting here, and I have my 4 meetings here, I have my B, I have my 120. At this point, I'm to apply the sine rule. Sine rule. So to apply the sine rule, this is my resultant. I have the opposite angle. And then I have 3 meeting here, I have the opposite angle. So I can find this using the sine rule. So sine of the unknown angle B here over the 3 meeting here should be equal to sine of the 120 all over this distance 6.08. So my sine B will be equal to 3 times sine 120 over 6.08. So let's see. I'm going to solve this. So 3 multiplying sine of 120 over 6.08. So that is going to give me, so I'm getting sine B to be equal to 0.4373. So sine inverse of this gives me B. Sine inverse of what? 0.4373. So sine inverse, and the angle I'm getting beta is equal to 25.3. So let me make it 25.3 degrees, right? So now the magnitude is 6.083 and the direction is was 25.3 degrees. And this is equal to the resultant. Thank you for joining me in this video. Please subscribe, like, and share.